OOP, or Object-Oriented Programming, is a programming paradigm that helps organize and reuse code more effectively. It exists in many languages, like Java, Python, and C++. One major feature that distinguishes C++ from its predecessor C is its strong support for OOP. While not always required, OOP is especially useful for building and maintaining large-scale applications. In OOP, the main building block is the class. You can easily modify our previous structure to create a class. Each class is designed with the idea that it forms a purpose for your application.
Classes are their own custom data type, just as structures. In C++, structs and classes are nearly the same. When you set components of the class like public, the class acts nearly like a structure. It helps to store many variables in one variable of a type class.
We can assign to a member of the class and print its values exactly like in the case of the structures.
One advantage of the class over a structure is that its components can be easily changed to private. Meanwhile, in the structure, its components are public by default. This is the usefulness of a class. The so-called encapsulation is the ability to make data members private and restrict direct access to them. Instead, controlled access is provided through public methods. While you can do this with the structure in C++, structures are usually used as plain data containers, while a class is preferred when you want to combine data plus rules plus behavior.
A constructor is a function that always has the same name as the class. It is used when you want to initialize the object's members, especially when they are private and cannot be set directly from outside the class. Regular functions in the class are called methods. So, why is a class here stronger than a structure? Data, M, D, and T, is private, so nobody can modify it directly. Planets can only be created with valid data through the constructor. Behavior, like printing method, is bundled inside the class. If you tried this with a struct, anyone could freely overwrite earth.m or leave it uninitialized, which makes the program error-prone. The takeaway is, use a structure for plain data containers. Use a class when you want data plus rules plus safety plus behavior.
Another advantage of the classes is the inheritance. Inheritance allows you to create a new class, child class, in our case, exoplanet, based on an existing one, parent class, in our case, planet. The child class automatically inherits the parent's accessible members, that is, public and protected variables and functions. Private members are inherited as part of the object but cannot be accessed directly in the child class. In our example, the exoplanet class inherits mass, diameter, and orbital period from planet, even though they were not defined inside it, so they can be printed in the terminal. It was possible to access the inherited members, mass, diameter, and orbital period in the child class because they were declared as public in Planet. If they had been private, the child class would still inherit them, but it would not be able to access them directly. You'd need protected members or public getter-setter methods. The best way to understand classes is through practice. Classes are an essential part of C++ and are widely used in large-scale applications. The more you experiment with them, the easier it will be to design robust and reusable programs. For more videos, don't forget to subscribe.